Good afternoon, everybody. Yeah, it's a great pleasure to see so many people here. So let me start. You see here the words AI and energy. What is the first which comes to your mind? I strongly believe that most people first think of the enormous energy consumption of today's AI systems. And indeed, AI has an enormous energy problem. You see it basically weekly on the news. So here you see, for instance, Forbes. AI is pushing the world toward an energy crisis. And let me now show you how serious the situation really is. So here I brought you a figure from the decadal plan of the Semiconductor Research Corporation for the Biden administration. What you see here plotted over time is the world energy production in white. And I would now like to show you the curve of the energy we just need for communication. So communication between AI agents, also communication in AI systems. And this is how it looks. And I'm sure most of you realize the seriousness of the situation, because certainly we cannot use more energy than the world energy production. If there's a limit, then this is it. Now, if you're a bit smarter, and we use, for instance, instead of CPUs, GPUs, we can lower this curve, but always remember, this is just the energy we need for communication, just a part of the energy we require worldwide. And already there, we are heading towards the world energy production. So I think, therefore, it's fair to say that AI has a serious energy problem. But AI not only has an energy problem, in fact, it has impacts on various aspects of our environment. So, and here are a couple of examples. For instance, these large-scale, hyperscale centers produce a lot of carbon. So carbon emission is one problem. And with it goes hand in hand also the emission of PM2.5. Now, what is that? So these are the small particles in the air which cause air pollution. And we all know that this can cause serious health problems. In addition, these servers are extremely hot. They typically are cooled by water. The water is heated up, so that first of all needs a lot of water. But then secondly, the water is released in the environment and could also be one reason for the loss of biodiversity. In addition, the data centers constantly need to be replaced, need to be improved, so this leads to a lot of electronic waste, and also, at the same time, certainly, it's also resource depletion. So, in that sense, we are right now at crossroads. We can continue the path, which we did now for many years. We can build larger and larger and larger AI data centers with similar technologies, or we can take a disruptively novel approach, developing and introducing novel AI hard-software combinations, AI systems, and shift gears and take a path towards a more sustainable AI future. The choice is ours. And so this was one of the two main topics which we discussed in yesterday's workshop, where I had the honor and pleasure to be the curator of. So this was a workshop on navigating the impact of AI, environment, and energy for a sustainable future. And my colleague, Shuguang, and myself will now present to you the results and the discussion of this workshop. We had a very high-profile set of speakers and panelists and moderators, both from science, so researchers, also from industry representatives, and also many policymakers from politics. I myself will present the scientific side, and Mrs. Shuguang will then present the viewpoint, the perspective of industry, and also of politics. So let me start by discussing from a scientific viewpoint the environmental aspect. Now, we heard several talks that rigorously scientifically you can show the tremendous impact on environment, for instance, concerning the enormous amount of energy consumption, of CO2 emission, of, for instance, also carbon intensity in the vicinity of hyperscale data centers. And at the same time, there was also a report that already in the vicinity of these hyperscale data centers, there was an increasing amount of PM2.5, which already caused serious health issues, and certainly with that comes also an enormous economic cost. At the same time, certainly we all know how fast AI accelerates these days. So now we have generative AI, we use cloud computing, and so on. And so what was also discussed is because of that, certainly this impact on environment also exponentially increases. And if we talk about cloud computing, I mean, that sounds nice. Something happens in the cloud, we don't have much to do with it. But I mean, cloud computing just means these are also still massive data centers which are on the ground, maybe also in a different country, but it's nothing which, I mean, we don't need to worry about. And what was also discussed from the scientific side was that there's a great need also for new metrics, and in particular, a worldwide fair assessment of the impact of AI on the environment in different ways. And science is also a good way to do that because science is in that sense independent and it can allow a fair assessment, a fair and rigorous assessment. And so let's now come to the industry side, and I will hand over to my colleague, Shuguang, please.
Thank you so much, Professor Gitta, and apologize I cannot speak as fast as Professor Gitta, but I would try my best to be faster a bit. And also thank you very much for ITU for this invitation and this very good organization for good to let us have this platform to exchange our ideas. So back to my topic today, I will talk from the industrial perspective on the AI environmental impact. Firstly, I think all of our industry partners already aware of energy consumption or water consumption in data center. I am sure on this. But how to tackle this or how to do in next steps, I think the first important thing is cost. Because you have to use energy-saving technology, you have to use the energy-efficient, maybe product, maybe department, etc. Then you need some support from foundings, etc. So it is the industrial part is also challenging, facing these challenges. And the next one, what Professor Gitta already mentioned from the scientific side, we have to have some metrics to evaluate how AI modules, how AI service, GHG emission or environmental impact. But actually, in ITU, for example, we have some recommendation already, but how to apply this in the industrial side, how to test this metrics could work very well, and if we need some modification work or updates, this is another work. The third one is for the AI, everyone knows, okay, now energy consumption is usually going very fast, but saying besides this, of course, we agree, but we also have to take care of water consumption, materials use, etc., e-waste problem maybe. So the environmental impact is a broader terms or broader scope than only for energy consumption, but of course biodiversity, etc. So now, very important thing again, on the software side. All of us know, okay, now servers are consuming a lot, but because of AI modules, we have to realize the functions first. Then everyone is just working how to get to the target on how to use these modules, how to develop these modules. But maybe at this stage, not so many people care of how energy efficiency of the softwares, how it can be more efficient. So this is the, facing challenges in AI environment. Then we would like to give some solutions, beginning from scientific side.
Yeah. Thank you.
Thank you very much.
Yeah, so let's come also a bit to the positive side. We heard just the impact on AI on the environment, what can happen or what happens these days. But at the same time, there's also great hope. And let me report from the scientific side, what talks we heard to tackle these challenges. So one main aspect was that certainly we can improve the software. We have our large foundation models. There are now ways to compress them so that training and inference doesn't use that much energy and doesn't use that much cost. There are also ways, for instance, if you have a large-scale model, you can repurpose it and use it for different purposes, for different tasks. Also, you could, for instance, do quantization and a lot of fancy techniques to reduce the consumption, the energy consumption, the requirements, the efficiency of your software. But what also turned out from a foundational viewpoint was there is also a serious problem with the hardware we use these days, in particular with the digital hardware. So everyone who has a laptop in front of you, you use digital hardware, and that requires a lot of energy. Because on the other hand, your human brain is an analog machine, and your human brain only uses 20 watts. So therefore, there are now technologies and hardware which go in this direction, for instance, neuromorphic computing, which use much less energy. So in that sense, what needs to be done these days, and that was also an agreement, is to not only improve the software, but to rethink disruptively this combination of hard and software together, to then get to a more sustainable future so that you can then create AI systems which require much significant less energy. And so this also shows that from a foundation, from a scientific viewpoint, you can really go to the depths of the problem. You can understand why these problems are caused, for instance, here concerning the hardware, and then also in a very systematic manner and also sustainable manner derive solutions which then carry also forward to the future. What was also discussed was, for instance, that it is very important for future AI technology to promote also energy efficiency, maybe as one of the core values, which could then also lead to the fact that people reconsider the way we do computing these days and rethink it in such a way that they also consider the aspect of how can I make it more efficient, more energy efficient, more friendly to the environment from a scientific viewpoint and also from an industrial viewpoint. And with this, I would again like to hand over to my colleague.
Thank you so much. Actually, from the industry side, we will not talk very, frontier technology. Just now we are saying analog and digital technology, also brain. Just let us consider from industry perspective, where GHG emissions from? Guess where it is from. Maybe all of you know it is from the fossil energy. Then the first one, from the supplier part or energy supply, we can do it green. Green energy supply is for AI is one, green AI. It could be done very easy, but it costs much. This is the first way. We did not encourage only in this way, but it is one possible way. Another because this is the supply part, then one equipment or AI is running, they are producing GHG emission in a process. Then you could have energy-saving technology wherever in servers, in supporting infrastructure, etc. Then you also can have very efficient product. It is not decided by AI itself, but it is very important point, can decide when it is running, for example, AI modules are running 10 years, the GHG emission is how much. Then also, we have the circularity, where you may circularity on the energy, circularity on the materials, etc. Then they could usually help us to decrease the GHG emission in the process of AI. At the very end, we would like to reduce at the supplying side. We would like to reduce at the inner process, but it's still there. GHG emission is still there. How to do it? Then you have to take care of them very accurate way. Then we have the standards. We have the solution on GHG emission management. You have to identify which is the most important parts to take care, where you have to decrease GHG emission. This is the three logic in the industrial part to have these solutions to decrease the AI environmental impact. So now we would like to turn to another channel for AI positive impact. So please start from the scientific side.
Thank you very much. Yeah, so we just discussed the impact of AI on the environment, but AI also holds a great potential for the environment. And so here I brought with me a statement from the World Economic Forum, 9 ways AI is helping tackle climate change by, for instance, monitoring how the climate is changing in different areas, also predicting how it will evolve, and also making suggestions on how could we best and optimized tackle this. And certainly climate change is not the only way where AI can have a significantly positive impact. There are also many other possibilities. Every city, every country has a power grid. You can optimize it using AI. You can optimize, for instance, also agriculture. When do you harvest? How is the weather predicted? You can do waste management, for instance, with embodied AI, robotics, improving this. Also conservation and biodiversity is a key topic. We had, for instance, a very interesting talk about deforestation, how you can predict it with AI, and how you can also then prevent it to a certain extent by looking at where this happens in the most serious cases. And then also transport and mobility, also one, let's say, aspect of environment which could be significantly improved using AI. So let me start again from the scientific perspective, how we can discuss this, what talks were given. And so one general agreement was that certainly these ecosystems are closely linked. So if you want to use AI for the environment, it should be also a global effort, a global cooperation. We need also metrics, human-centered metrics, to then carefully assess how good the optimization was done. Research could then provide the newest AI technologies for tackling those challenges. This requires highly interdisciplinary teams. And also with research, with science, we can very reliably provide not only methodologies, but also predict risks, such as, for instance, there's a data gap, this method cannot be used. We need to go in this way and approach it from that perspective. And now let's again come to the industry perspective.
Thank you so much. Then we move to the industrial part for the AI, what AI could do to the other sectors. You know, all the aspects you may already aware, decreasing energy consumption, also water consumption in the data center, yeah? And not only for data center, sorry, but other sectors, and also cutting down the material use, circularity, biodiversity, GHG emission, etc. So we would like to bring some researching work and the use cases you may can understand a little bit deep. First one is some organizations, including, first of all, ITU, also doing the research saying ICT, including AI, could decrease or enables 15 to 40% of reduction of GHG emission globally. So another also from the JESI, from the GSMA, also have some different perspective, but the result could be always the same, 20% reduction in JESI, and in GSMA is 10 times greater than itself, but itself is 2%, so the same with 20, And some solutions from different organizations or industries globally. First one I would like to take an example is on the manufacturing industries. We can use AI for different steps. First one is manufacturing devices. You can control the devices with AI technology, and it can save energy. Then also manufacturing process, and for all the management work, then you can have generally saving energy or using green energy, and for recycle and reuse. This is, I say it again, not only for ICT or AI itself, it usually goes to another sector and helping them to decrease the GHG emission. Then another very important point or area is energy sector. They are also using IoT or AI technology to let them get the data with the sensors, and using network to transport the data, and using the AI deep learning technology to save energy and promoting green energy transition. So at the very end, we would like to say, okay, now it is not divided into AI itself or AI for environment. It is normally, we say, first one, from the scientific side, we have already talked a lot, technology breakthrough. We have already identified, here is very key area we have to put the technology breakthrough, for example, in the chips, to push AI more sustainable. And policy and the regulation is another very important topic yesterday in the workshop. Some countries are saying very important on the policies and regulated to collecting the data, but some countries also say we would like to collect, but the regulation is first to control how to put this data safe, etc. So this is the work we are discussing. It did not put very precise direction, but we have get the consensus, collecting the data, and do the deeper work is very important. Then we have standard development in ITU, for example. We have plenty of standard in ITU study group 5, which we are working a lot, and we can use this standard to promote the AI environmental impact, not promoting decreasing impact, and promoting the sustainable development. Then the last one should be like international cooperation. Here we are taking. We would like to put this AI, green AI development, inclusive, no one behind, no one left. So at the very end, at last but not the least, here are 4 very important reports released from yesterday's workshop. Due to the time limitation, I will not read one by one, but please again, QR code to get this very important report and go into further steps. Thank you very much for all of your attention, and thank you ITU for providing us this. Thank you.